Hi everyone, it's Logan here, and I wanted to bring you an unboxing of this. It is a digital panel meter with a shunt. I thought there might be a few of you who are actually pretty excited about this, because I am. So, what is this? Well, it's actually, like it says, it's a meter with a shunt for amps and voltage. So I have a digital multimeter, but it only works up to about 10 amps. And that's not good enough for the motor I'm building. That's drawing a whole lot more than 10 amps. In fact, when I was using the power supply, which maxes out at 10 amps, it was hitting the wall. It couldn't go any further than that. So I decided to buy this. It wasn't terribly expensive. I got it off eBay. So let's see, what do we got? We got an operating manual there. And let's see what that says. It's actually good for up to 100 volts and 500 amps. And working current, so it only uses 70 milliamp, range of up to 24 volts, input, resolution of 0.1 amp or 1 amp depending upon how much it's actually measuring. The shunt must be used. So basically, before I actually get into it here, the whole way that this works is by shunting current off of the main thing, because there's no way that this meter would actually be able to read 500 amps. I mean, it would blow out easily. So what it does is that it shunts current from the main line, the main power source. So here it is. What do we got here? This is the shunt. Oh man, that is heavy. I'll open it up here in a minute. And then we have the actual meter itself. And what else we got? We got the connection there. So, let's see if I can do this with one hand here. Alright, so this is the shunt. So basically, you're going to take whatever incoming lines of power and put it there. You're going to clamp it down and then outgoing there. So the current goes right through here just like it ordinarily would, up to 500 amps. Works just fine through this. Has very little resistance, can dissipate the heat very well. I don't think I'm going to need 500 amps, but I could have gotten a cheaper one, but I figured let's do this right. Because this way, maybe if I have 4 motors running at once, I can measure all 4 of them. Here we go, here's the panel. I'll be back in just a minute when I get this open. Alright, so here we go. Got it open now. Let's take this protective cover off here. There we go. So it's actually quite simple. Basically you're just gonna, I think, end up soldering this. Oh, there we go. You're gonna connect it there. Of course, follow the instructions. And then you're gonna end up connecting this to these points here. And as the current flows through, it's going to divert just a tiny amount of the current off into the meter, but there's a known resistance in here. So by measuring the voltage difference and the amount of current that's going through it, away from the shunt, it can actually, through a formula, calculate exactly how much current is going through there and how much voltage. So hope to show you how it works here either later in this video or another video. But yeah, I'm really excited. Alright, as an addendum, I just wanted to show you that I got it working. So here's how it actually hooks up. So this is negative. This goes directly to your power source, in this case the battery. The yellow from the shunt goes on this, or the yellow from the meter goes on this side of the shunt. The green goes on this side of the shunt. And this is what's coming from the load. So it's hard to tell, but following that, it's basically coming directly out of the load, which is in this case the motor. And then what goes into the load is directly from the power source, in this case the battery. And then the white connects before it goes into the load. The other thing is that you need a source for it, and you can technically use the same source as long as it's connected by different wires. Otherwise it'll screw it up. But you need, the best way to do is a separate source. So in this case, just a 9-volt battery. It is powered on. You'll see it in just a minute. And Basically what's happening is it's reading the voltage before it goes in, and then it's reading it after it comes out, and it's determining the voltage drop. Then it can determine the current based on the voltage drop across here, which it's known the amount of resistance that's in here. Then it uses that to calculate it and show it. So I'm going to show you this in a second. I had this up. There's only 2 phases that are working right now, 2 of the 3, because I actually ran out of alligator clips. But with the 2 phases you're going to see here in just a second, I had it up to about 800 RPM. So here we go. So there we go. Now it's reading 11.9 volts, so you can tell the battery's getting a little weaker. It's up to well over 12 before. And it's drawing about 10 amps right there. And we'll see if we can show this here. There we go, 845. 850. So there you go. Now it's slowly going back down. So there you go. That's how it works, and it can go up to 500 amps is what it can measure, and I believe 100 volts. This has to be connected to, I think, between 7 and 24 volts separately. So thanks for checking this out. Like if you like it, and let me know what I can do better or what else you want to see.